Hello everyone and welcome to this new video of the IGCSE chemistry. Today we're going to be talking about the paper 5, which is alternative to practice, and specifically we're going to be talking about how to identify unknown substances. So tests for unknown solutions or for unknown solids. This is very important because these exercises normally have between 7 to 11 marks, and this is about 20 to 25% of the whole paper 5. So this is very important. For today, I have one example, and this is very simple. A student tests two substances, solution E and solid F. And here we perform the test on solution E. Solution E is aqueous chromium tribromide. So in this example, we already know that the solution E is aqueous chromium tribromide. Let's try to transform this into the formula, which is Cr. We know that the charge of this cation is 3+, and we have bromide, which is minus, and remember we have to cross the charges. So the actual formula of chromium tribromide is CrBr3, right? And we know that solution E is divided in two portions. So we're going to have solution E portion 1, and then we have solution E portion 2. So question A. To the first portion of solution E, the student adds aqueous sodium hydroxide dropwise and then in excess. And you might be thinking, okay, so when did we learn about adding sodium hydroxide dropwise and then in excess? And what about the observations, and should I know this? And the answer is not really, because for these specific tests you will have like your best friend, and this is called like notes for use in qualitative analysis, and this is gonna be provided to you at the end of the paper, so you don't have to worry to memorize all of these tests. However, for paper 4 and even paper 3, sometimes they like to ask you about some tests. So for example, oxygen or hydrogen, that are tests for gases, but these are pretty used during the syllabus, right? Not like the test for zinc. Okay, so something very important to mention here is that here in the notes for using qualitative analysis, we have tests for anions, tests for aqueous cations, here tests for another cations. But the difference between these cations and these cations is that this is called the flame test. So we have to put the substance into the Bunsen burner, into the flame, and look for the color of the resultant flame. We also have the test for gases, that we have covered these tests in the syllabus. So these are more familiar. So now let's go back to our exercise. And here they say that the student adds aqueous sodium hydroxide dropwise and then in excess, and they ask for the observations. So please remember, observations here are actually observations. So this might be obvious, but observation is what you can actually see. So if there is a formation of precipitate, if there is a color change, if the solid disappears or dissolves, if there is fizzing. But please do not put like, oh, this is a redox reaction, because what? So we can observe really a redox reaction. We can observe that there is a color change. So this is the objective of observations. When they ask for observations, you can put what you can see. So here we have what are the observations when we add aqueous sodium hydroxide? So we have to come here to the notes and look at this. We have specifically notes for when we add aqueous sodium hydroxide. And what we're trying to do here is try to test cations. So something that is very common in this kind of exercises is that you have an anion and a cation. So here the solids and the solutions are formed by cations and anions. So we're always trying to identify cations and anions. So because all of these compounds are normally ionic compounds. So let's go back, and here we have the tests for aqueous cations, and here we have effect of aqueous sodium hydroxide on different cations. So in this exercise, we need to check what would happen if we add sodium hydroxide to this that is going to be our cation. Because remember, we have CrBr3. So our cation is Cr3. So we come here to the table and identify Cr3. And what's going to happen that when you add NaOH, you're going to have a green precipitate. But then if you add excess of NaOH, you will have that this precipitate is now soluble. So that are our observations. So what happens when we add NaOH dropwise? A green precipitate is formed, right? But what would happen if we put NaOH, remember NaOH, in excess? Well, the precipitate dissolves. Why? Because the result says that the precipitate is soluble in excess. You can also put here, remember, the IGCSE wants you to show that you know and understand what's happening. So this is not the only option. You can also say the precipitate dissolves or the precipitate disappear. Okay. Now, let's go to the second portion of solution E. And it says the student adds about 1 cubic centimeter of dilute nitric acid and a few drops of aqueous silver nitrate. So now we need to go to the table and look for the effect of adding HNO3 and silver nitrate. Now look at this. Here you have the effect of sodium hydroxide, so this is not an option. Effect of aqueous ammonia, not an option. Flame test, not an option. Gases, not an option. So the only thing that you have here is like the test for anions, and this makes sense. Why? Because remember, you have already checked what happened to the cation. So to this part is done. So now we need to check what happened to this part here. And this part here, remember, this is an anion. So we here are going to test bromide ions. So we come here and look, dilute nitric acid and aqueous silver nitrate. And the result is that when you have bromide ions and you add this, you're going to have this. The test result is a cream precipitate. Okay, so the observations here when you add this is that a cream precipitate is formed. And please remember that when we say that a cream precipitate is formed, we're talking about that a precipitate that has a cream color is formed. Okay? Very good. So we have already gotten 3 marks here. Okay? Now, we need to check for solid F. We have a solid F. In this case, this is an unknown solid. And please remember, here we had a compound, an ionic compound, a cation and an anion. So normally what we need to do here is we have an unknown solid And we need to identify what solid is that one. So we probably will have a cation and an ion, and we don't know. So here, this table shows the test and the observations. So now this is the opposite to this one. Here we already know the compound and we just need to check. And here we don't know the compound, but we have the observations and then we have to come back. So here about half of the solid F. The solid F has a 100% of this, and here we have like the 50% of this is going to be heat up in a boiling tube and until there is no further change. And what you can see from that, the white solid forms a colorless liquid. Steam comes out from the boiling tube. So what you're gonna have here is, imagine a boiling tube that has this, which is the unknown F solid, right? F solid. You're going to heat it up, and when you do that, steam is produced, and you are going to see that because it's going to condense. This steam is going to condense at the top of the boiling tube. So here you will have some drops of this liquid, right? That we will see that this is actually water. Okay, why? Because you have this salt. Remember, we have this Ca, which is our solid F. So remember, F is formed by a cation and an anion, and suppose that this salt is hydrated. So if it has water, when you heat it up, you will have steam, and that steam will condense and form water at the top of the boiling tube. So what can we conclude? And here, there is something here. We have the questions here, but I'm trying to show you what information can you get from here. So the observations or the conclusion of here of the test 1 is that our compound has water. Now we have to do test 2. The remaining solid, so the other 50%, is dissolved in water to form solution F. And this solution F is going to be divided in 3 different portions. So this 50% is going to be solution F, and from solution F you have 3 portions, 1, 2, and 3. To the first portion, so to portion number 1, we put it in the boiling tube, and then we add aqueous sodium hydroxide dropwise and then in excess. So same thing, we have to come here and look that the observation is that there is no change. So we come here to our tables and look, here we have that when we test for aluminum, we have a white precipitate. For ammonium, we have ammonia produced. For calcium, we have a white precipitate, green, light blue, green, red, brown, white precipitate when we move down the table. But here we don't have like a information of no change. So basically what we can conclude from that is that the ion that is here, or the cation of solid F, is not aluminum or ammonium or calcium or chromium or copper or iron or zinc, right? So here we have no idea what our cation is. So we still don't have information. Second, warm the product and hold damp red litmus paper at the mouth of the boiling tube. So we put the damp red litmus paper, and it says that it remains red. So if it is remain red, so we actually don't have any information of that. The only thing that we know is that a base, right, is not being formed. Okay, please look at this. This warm the product and hold damp red litmus paper is actually a test for ammonium. Look at this. When you come here, you can see that when we add sodium hydroxide and then we have this ammonium ion, we will produce ammonia. And then if we want to check for ammonia, we have damp red litmus paper and it turns blue. So what we're trying to do here on the second part of the test too is check for ammonium, right? For the ammonium ion. So a base is not being formed. So our cation is now NH4. So we don't have NH4, but we also don't know what we have. Okay, so move to test 3. To the second portion of solution F, remember we had 3 portions, now we have the second portion. We add 1 cubic centimeter of dilute nitric acid followed by a few drops of aqueous barium nitrate. So let's try to come here. So we know now our solid F, we have a cation and an anion. We couldn't identify the cation, so let's try to identify the anion. And what we try to do here is add nitric acid and barium nitrate. And here we have that white precipitate is formed. So we come here, and look at this. What happened when we add nitric acid and barium nitrate? A white precipitate is formed. So it means that this test is positive for sulfate. So what conclusion can we have from this test? That we have the sulfate ion. So our anion is sulfate. But what about the cation? We still don't have any information about the cation. So let's try to wait for this. Test 4. To the third portion, add a few drops of acidified aqueous potassium manganate. And it says that the solution becomes light purple. When the solution becomes light purple, remember that here we have aqueous potassium manganate, which is the MnO4 minus ion. And remember that the color of this ion is purple, right? This ion is purple. So when we add this ion to a solution and the solution becomes purple, is because this ion didn't do any effect to the solution. Remember that this is a very strong oxidizing agent, and this normally reduces to Mn2 plus, because this is plus 7 here, and it reduces to 2 plus, and this is colorless. Okay, so this test actually do not give me any information. So let's try to go back to the table and look for this. When we add a small amount of aqueous potassium manganate and the solution turns from purple to colorless, then we have sulfite. But it says that the solution becomes purple, not colorless. So we have negative for sulfite. So let's go back to the questions. Here in test 1, it says that it shows that solid F is hydrated, as we said, right? Because it has water. So the results of the observation shows me that this solid has water. So now we have to describe a chemical test to show that the condensation at the top of the boiling tube contains water. This is very simple. And for this, we have to remember something very important. And is this image here. And please remember, this is copper to sulfate. But when it is blue, it means that it is hydrated. But when it doesn't have water, when it's like this is white. So please remember, this is the test for water. Always remember that. We also have another option, which is with cobalt chloride, but normally let's try to use this one. It's easier. So how do we do this test? Well, it's pretty simple. We have to use anhydrous copper to sulfate, right? And what is the result? That when you add the water, it turns blue. It turns, or let's try to say that it changes from white to blue when water is added. Perfect. Now, from the tests and observation in table 3.1 is not possible to identify the cation in solid F, right? So here we need to suggest another test that can be carried out to help to identify the cation in solid F. So if we cannot identify the test using this table, we only have one chance, and is use this table. So we can do a flame test to try to identify if we have lithium or sodium or potassium or calcium, barium or copper. Okay, so our answer here is we can carry out a flame test. Okay, and the last question is identify the anion in solid F. And as we did before, we know that the anion in solid F is sulfate. So you can put sulfate, or you can put SO for 2-. And that's it. It's pretty easy. It's not that difficult. So I will be uploading more videos using more examples. So thank you so much for watching, and see you next time.